Okay, as you can see, our next topic is going to be about conditional probabilities. Um, we've had independent, we've had dependent, we've had mutually exclusive, we've had inclusive. Now we're going to be dealing with what does it mean to have a conditional situation. So dependent events and any conditional probability. And dependent really is because you have one thing depending on the other. So let's look at some definitions. Dependent events. Two events are dependent if the occurrence of one event affects the occurrence of the other. So I like that, but that's what you got to remember. That key piece. One event affects the occurrence of the other. Or if the events are not independent. Okay? Conditional probability is the probability of event B given that event A has happened or will occur. And look at the new notation. P parentheses B vertical line A close parenthesis. So it's a new notation that we definitely want to look at. And down here it's described as P probability of the event B given that A has happened or will be happening. So P B of A slash B given A is how you read it. Should be the probability of A and B happening. And remember we did something about probability of A plus the probability of B and then minus the probability of A and B happening. And that's all going to be divided by the probability of A. So knowing that, look at this first situation. And that's again, it's going to be a word problem. And if you have the high school honor society, has 20 members. School's debate team has 18 members. But 12 members of the debate team are also in the honor society. Suppose that a student is randomly selected from these two groups. Find the probability the student is a member of the debate team if it is known that he or she is a member of the honor society. So if we talk about our new notation, we're thinking probability of, and they ask, they are going to be a member of the debate team, so we'll go debate, given they are a member of the honor society. So if you can count up that combination, if it's a small combination, or if you can do the math and the formula that we had on the previous page, but I think if you read carefully on this one, that you have been told that you have 18 out of, 12 members of the debate team are also in the Honor Society, and the Honor Society has 20 members. So 12 out of 20 is the number combination you should be looking at, given the Honor Society. So 12 are debate, given we have the whole Honor Society, and I think if we check, that 12/20ths or 60% is the solution we're looking for. Okay, let's try a different combination. This one's marbles. A bag contains 5 blue, 8 yellow marbles. For each case below, find the probability of randomly selecting a blue on the first straw and a yellow on the second. Okay? So this time you're thinking, yeah, one has to happen then the other, but probability of blue, or you could say probability of yellow given a blue on the first. Any combination like that. So you're thinking, okay, the first marble is replaced. So that means we are going to put it back in the bag. And we have 13 total in our bag. So that's key. All right. So if we said, what's the probability of getting a blue on the first straw? We'd have the probability of 5 out of 13. And then, because they have nothing to do with each other, put that marble back in and select a yellow on the second draw, we would have 8 out of 13. So there's our work. Multiply it out. Cancel if you can. Check it. Did you get 40 over 169, which then reduces to 23.7%? The second choice is we're going to do the same draw, but this time the first marble is not replaced. So if we do the same situation and get 5/13, what are we going to have to do, or how is it affecting our second draw? So 5/13 was the first, nothing's affected, but now we're not going to put the marble back, and we want a yellow on the second one, so we'd have 8 chances out of now a total of only 12. 8/12, so you could reduce that and multiply, or you could just multiply. If you want a percentage answer, then you can see we've got top times top, bottom times bottom, cancel and divide, and our final answer was 25.6%. So from there, we have one more situation, and it's just if you're going to do these dependent and conditional probabilities, make sure you do look at what happens on the first, and if it does affect or if it does not affect what happens on the second. Okay, so it's usually going to be 2 events, so we'll talk about those more in class. Bring any questions you might have with you.